So good afternoon, everyone. Thanks for joining this session on the role of AI in the future of the 5G technology. I'm very glad to welcome on this panel uh, General Kochhar, who is the Director General of the Cellular Operators Association of India, which is the nodal body for advocacy on policy and regulatory issues in the mobile sector. So warm welcome to you, and thanks for joining.
Thank you so much.
In this session, sir, we will try and address a couple of questions, core questions revolving around 5G. To start with, sir, I would love to hear your views on the core themes. I think spectrum auction is going to be the determinant for how the 5G rollouts will happen. What, in your view, is the next step for this? When is it going to happen, and what are the next steps?
So that's a great question, Gajan. That's actually the lifeline of 5G, and we've been harping on that. There are many questions revolving around spectrum. The primary, of course, is the costing of spectrum. The costing has been rather high in the previous auctions, and if the same trend continues, we'll find takers to be very few, because the costing of 5G has to be quite different from what it was for 4G. And the reason is not far to see. For 4G, there was a ready-made ROI. In 5G, it won't be there. We have to still find and grapple with use cases and then come out with ROIs, which will take time. Also, we must understand that 5G is an enabling technology and not only a telecom technology. And therefore, the revenues which come by having sectors ride on 5G will be much higher than the revenues which government can get only by putting high prices on spectrum and get the revenues from telcos. So if the government doesn't miss the woods for the trees, they will understand that the cumulative revenue they will get from the industries that ride on telecom and enhance their offerings and their revenue sources will be much higher than what they can ever get from only spectrum auction. So that this is a different paradigm, and it must be seen in that light. Second part with spectrum is identifying the bands and identifying which all bands are going to be put up for auction. And here, government is doing a lot of work. They are in the process of identifying, rationalizing, cleaning up the bands that they have prospectively aligned. Once that happens, we will get adequate amount of spectrum so that we can offer 5G services as professed by technology. Otherwise, it will be a hodgepodge, and it will not live up to what is expected out of 5G by subscribers and by the general populace. Third thing is spectrum has to be both access as well as backhaul. And what we are insisting with the government is that the backhaul and the access should come as a bundle. Okay, otherwise there will again be there'll be bunching where the access finishes and backhaul takes over. There will be a problem there. Hence, we are asking for spectrum to be bundled together. And anybody who gets excess spectrum by auction should also be allocated a backhaul spectrum of a sufficient quantity. Even if all this is done, there will still be instances where we will not be able to lay fiber, and we will have to connect various infrastructures on wireless. And in this, I'm referring to the ENV bands, which are also colloquially known as fiber in the air. So they will afford adequate amount of capacity to take from one BTS to another BTS, the 5G traffic that flows. Now, this will be essential in densely populated areas where digging is impossible, as well as in sparsely populated, difficult terrains, difficult because of geography or difficult because of operations like LWE, the Naxalite area, the maybe border areas where the terrain is not conducive to laying of fiber or maintaining fiber. So there, this sort of technology will come in very handy. And this is another case that we have taken up as far as spectrum is concerned with the government. Now, spectrum is one thing. The second thing is about the infrastructure which will connect the BTSs together, the radios together. That is densification of fiber. So at this time, you're aware that only about 30% of our towers are connected on fiber. With 5G, this will become very critical because 5G will generate huge amount of data, and that data has to flow on fiber, and hence the connectivity of towers on fiber is not staring us in the face, and it is very essential. Otherwise, we will have a lot of problems in taking that type of data. In this, the TSPs are very keen to lay the fiber. The government is very keen that the fiber gets laid. The problem is in the ROW issues that come up. And this is something which we have to address. The government is trying to address it. We have not been able to address it to the extent that we desire to make fiber a seamless rollout. But we are at it. Government is at it. Hopefully, the states and the local bodies will see sense in this and stop charging absurdly high rates, which are not in consonance with the central government directive, nor are they uniform across the geographies. One place it is 10,000 rupees as stipulated by the government. In other place it is 1 crore rupees a kilometer. Now this is the type of range that we are seeing. Permissions are difficult to come by. So all these things are being addressed centrally and
Right.
at our level. So this is one thing which has to happen. Now,
Right.
specifically for 5G, there's one more point which is going to be very important, and that is small cells. In the urban areas, small cells have to come up. It's not only getting the spectrum; it is also populating that area with adequate amount of small cells to give the coverage that is desired with the capacity that is desired.
Right, sir.
And for that purpose, we are looking at government coming out with some policy on street furniture, wherein where we can use existing poles, we can use various government infrastructure for mounting the antennas of 5G, so that we can cover the areas quite adequate. We are in consultation with both TRAI as well as DOT.
Right, sir. So that's an amazing number of unresolved policy and regulatory issues. I think that needs to be still addressed. One aspect that this brings me to, sir, is when you talk of the backhaul and the huge amount of bandwidth that is needed to carry the 5G traffic back to the main operating center, is the kind of use cases. So there is talk globally of 5G actually enabling two kinds of. One is the end user, the retail kind of customer. And the second use case is the enterprise level customer, which is more like a closed user group. Do you have any ideas, sir, in brief, what kind of applications we will see rolling out first in the Indian scenario?
See, I'll be very candid on this. As far as you and I are concerned, we don't really have a need for 5G for our personal use, okay? Because the speed that we get in 4G, if they become proper with proper densification and fiberization, I don't think we will spend that extra money to get into 5G, except for esoteric reasons. But the point is, what is 5G meant for then? Why are people talking about so much about 5G? Essentially, this is the first time that machines will talk to machines, machines will talk to human beings. Okay, and that is where the capacities and the low latencies come into effect. For you and me, whether it is 1 second latency or it is 0.9 second latency, it doesn't matter. For a machine, it matters. Okay, so therefore, for a sensor, it matters, right? So therefore, 5G's primary use will be in machine-to-machine communications, heterogeneous machine-to-human communications, as well as applications like IoT, like sensors, those sort of things, then industrial automation. and Industry 4.0 will be a big user. Will be a big user. Now, you're talking about whether it's going to be retail or it's going to be enterprise wide. Now, this the way I have explained 5G in the past 2 minutes would give you a sense that 5G will be uh, adequately employed only if there is adequate amount of use cases for machine-to-machine communication. Like in India, Industry 4.0 is coming up, so they will require. Then we are having disparate office branches of various corporates of government all over the place all over the country. Now they can have a slice, and they can have edge computing and yet be connected onto the network. You know, much like what we used to do in VPN earlier. This is much beyond that. So 5G will enable that. 5G will also enable high-speed communication. Like if you are traveling in a bullet train, 4G will not be able to give you connectivity. Bullet train, I'm only giving an example. You can even talk about aeroplanes, but 5G will. It will permit a huge amount of speed coverages which are permitted, and therefore that is another type of application that will come up. But applications will start developing now after the trials. The applications that are existing across the world may not suit India because we are not in that type of environment. Right? If you take the rural area, there's hardly any industrialization. So if 5G has to reach there, what for is going to be used? So therefore, there it may be that 5G will ride over existing 4G network, which means it will be a non-standalone deployment, but it will give higher coverages. For example, now in the trials which have been carried out by the TSPs, they have been able to achieve with prototype 5G equipment up to 20 kilometers of coverage from cell to cell. So that is a huge amount of coverage, right? Without changing the handsets, without changing the global handsets, right? So these trials will show where the applications will develop. In theory, we never thought it will be able to achieve 20 kilometers. We have, right? And therefore, this throws up a very good opportunity that number of subscribers can be aggregated in the rural area over one radio. And therefore, the number of the reach of 5G will reach to many villages by possibly mounting a 5G equipment over 4G. And those who feel that they require 5G can use 5G. Those who don't, continue using 4G. So that is the reason why it is a non-standalone deployment that will be looked at. In urban areas, in industrial areas, especially where there is going to be a huge amount of requirement for capacities and low latencies, there initially we may start with non-standalone deployment of 5G. But as time passes and the requirements of data go up, we may see requirement of standalone 5G coming up. And those are the things that you were referring to as industry, as enterprise
Sure.
customers, and that the TSPs are well geared up to provide both flavors, and it will not be a homogeneous deployment of 5G across the country. It doesn't make sense because the use cases are quite different, and
Right, sir.
therefore what we will see will be a heterogeneous deployment depending on the business cases which exist in that geography, in that segment, in that user's requirement.
Got it,
So
sir.
this is going to be integration of business and technology, which will dictate where what will go.
Sure, sir. So in the last few minutes, sir, I would like a very quick understanding from you. So when do you see the first 5G networks roll out? Sometime middle of next year, or maybe even the year after that in India?
Good question. But the variables that I pointed out to you have to be first addressed. They have to be optimized. So it's an equation. If the variable, we don't know the values of the variables yet, so we can't really come to what is on the right-hand side unless the left-hand side variables get sorted out. And therefore, if the variables get sorted out, I think we will be in a position to roll out 5G maybe by August, uh, definitely. And If they don't get sorted out, and it's going to take more time, and then of course the case may become different. But we have emphasized to the government that please look at these things very urgently, and they're doing it at the minister level. It is being addressed. So if it gets addressed and we reach somewhere where deployments can start, I think by middle of August, we should be able to roll out something.
Great, sir. So by August 2022, we look forward to 5G services, sir.
Yeah.
With this, I thank you for your time, sir, for this session.
Thank you. Thank you so much, Gajendra, and good talking to you.
So thanks, General Kochhar, for those views on the regulatory side of 5G. We now have with us the Chief Marketing Officer from Nokia. Nokia is the infrastructure supplier and the foundation for the networks that actually run the 5G services. Amit, thanks for your time and glad to have you here.
Glad to be here.
Thanks. I'd like to start, Amit, with a very quick question. General Kochhar mentioned that he expects the first networks to be ready by sometime mid of 2022. What do you think is the network readiness of the operators, and when do you think we will see them?
Okay, so I'll, what I'll do is I'll try to break the network into main 3 blocks, and for the simplicity and also understanding of the audience. So a telecom network has 3 fundamental big blocks. One is the core network, the other is the transport network, and the third is the radio part of it, which is radiating the frequency in order for you to be able to make and receive calls and data. So if you look at the last 2 years, what the operators in India have done, in fact, more than 2 years, is that they have been working on the core very intelligently. The next step to the core is the modernization of the core towards the virtual and cloud environment. So that journey has been ongoing even from the 4G times. And actually, when they started rolling out and upgrading the network with 4G, at the same time, they also took the initiative of virtualizing their core network into a more cloud kind of virtual network. And because that has already happened in the last 2 years, the core is right now ready to take the leapfrog into 5G. So if you look at the IMS, which is part of the core, or the HSS or the HLR or various other components, all of them right now are on a cloud platform. And from here to moving to 5G would be a relatively easy journey of a software upgrade, more or less, and be able to do. So the core has actually been taken care, and this is across all operators. The second part is the transport. Now, transport is very critical, especially when you do 5G, because what you're doing in 5G is that you are going to be carrying much bigger pipes between various nodes. So between the base station and the core, you will need a much fatter pipe, because 5G inherently as a technology allows you to take much more spectrum and give you much better throughput and bandwidth. Now, for that, one of the key requirements is large-scale fiberization. Today, we are sitting at about 30-35% or 30-33% of fiberization. Some operators are ahead, some are not so, little behind. But on an average, 30%, let's say, in India. Now, this 30% ideally should get to 100%. But generally, there would be some rural and semi-urban, semi-rural kind of deployment where the pipe requirement may not be that big. So you can still work on technologies like microwave in order to cater to that. So I would say my estimate would be like, this 30 needs to get to a 60 or a 70, a healthy number like that. And so that journey has also started in India. And actually right now in the last 2 years or even more, a lot of people have been spending, all the operators have been spending a lot of resources. Government has taken some initiatives, the NOFN program and, the NFS. There's so many things that are going on which are related to upgrading the 5G network. Yes, there is still way to go, but I think we are on the path. The other part on, again, backhaul or front haul is new technologies like E-band and V-band on microwave. So microwave is basically a point-to-point link between, let's say, a base station to another base station or base station to where you need to carry a shorter pipe. And that has a limitation today on how much you can carry. Now, there are technologies in microwave which will come with E and V band, which will make this pipe much bigger. So what will happen is That's in some sites today. Let's say you can when 5G comes, only 10% or 20% sites you can do in microwave. When E-band, V-band, maybe 30% sites you can manage with microwave or wireless link. So that way is going to change, and I think that is an initiative that the approval for that has to come from the government. And once that comes, I think it will be a welcome move. The last part is the radio part. Again, on the radio part, you need both hardware and software in order to upgrade to 5G, because you are going to be radiating in a new frequency. However, I can say today that more than 90 to 95% of the sites or the base stations which are deployed in India across all the operators are upgradable to 5G. So there is no reason that you need to forklift and throw them in the ocean and put a new site. So the same site which is today working on 2G, 3G, 4G, by adding some more hardware and software, can be upgraded to software. So I would say the journey is begun. That is why we are seeing most of the operators saying that we are 5G ready, and that's right, because they are 5G ready in the sense that there's a incremental step they need to take in order to get to 5G. So that's where we are.
Sure. Thanks for that. So Amit, you mentioned something about the virtualization of the network and the core part being, one of the steps towards this. So that brings us to one of the core themes of the DQ Tech Dive today, is to understand the hardcore technology and virtualization. When you mention leads to something called network slicing. I guess there's a lot of talk about network slicing and the kind of services that are being offered. Would you be able to throw some light on what is network slicing and how does it impact the network? Yeah.
So I think one of the key advantages. So 5G has mainly three big pillars. It is going to be giving us massive broadband. That means much more higher throughputs. It will be able to give us very low latencies, almost real time or near zero latencies. And it will be able to connect millions and billions of IoT devices. So those are the three dimensions of a triangle of 5G. But I think the core of 5G, how this is going to get transformed, is this technology called slicing. And for the audience, I will explain slicing in a very simple. You look at slicing as a highway, a national highway or a state highway, which is running across. Now, in that state highway, right now, you have a 4-lane and a 4-lane and a divider in between. So everybody goes on those 4 lanes. Tomorrow, you are going to create this highway into, let's say, even a 4-lane or an 8-lane, but each of those lanes will be designed for a certain type of vehicles to go. So the trucks will go on a single lane, the cars will go on a single lane and probably have a higher speed. There might be a lane for two-wheelers and cyclists and walkers are possibly going to have a separate lane. Now, why this is important is, number one, it will create an efficiency in the whole system. What will happen is that the need of all these individuals of using that road is very different. And now you have catered to that need. So slicing is doing exactly that. It is taking the network, cutting it into slicing, and depending on your need, you can say, I want this kind of a slice which requires very high throughput. For instance, I'm doing a video streaming application and I need low latency and very high bandwidth. So I need a slice for that. But yes, there could be a smart meter application where you don't need bandwidth at all, because you only need millions of devices to be connected. So you have a different type of network resources that you require. So that is what is slicing about. Having said that, I think, like I said, slicing will enable a large number of new use cases, especially when we go to different verticals, which is exactly what 5G is trying to do. Going into enterprises, going into various other industries which have not been so far touched by digitalization or touched in a limited way, and enable that. So we have a case, I remember I was reading in Austria, for instance, where we have created these slices for a train operator, OBB, I think. And we have a slice which has been created for a airport. The Vienna airport has a separate slice because the requirement is. So this is what exactly slicing is going to do. And I think this is going to be a game changer in the next coming few years in order to really make 5G usable.
Sure. So this really sounds interesting and a very, very different application for mobile networks going forward. In all of this, Amit, would you like to share a little bit on where artificial intelligence or AI plays a role in the future of 5G?
Sure. So AI has been in existence for many years. We know, we are all used to now working with bots and some kind of a artificial intelligence. It is there. We have the Alexas of the world, which is built on a algorithm of artificial intelligence and learns and relearns and learns more. 5G, as I said, is a technology which will basically provide you large connectivity, much more efficient connectivity at a much low latency with many more devices that can be connected. The building block of AI is what? It's data mining, right? It is learning, and as much data that artificial intelligence gets, the more accurate and more useful it becomes. 5G will enable that. So when 5G and AI come together, then the use of AI becomes multifold. It really changes the paradigm of how artificial intelligence can be actually used to create more efficiency in various kinds of systems. And I'll give you some examples of that. For instance, let's take a case of a factory. Now, in a factory, let's say you have these high definition, hundreds of cameras installed everywhere. Now, these hundreds of cameras on a real time are giving a feed into a server. The server is looking at all these images and actually trying to analyze defects. And on a real time basis, taking a proactive action in order to improve that defect. Now, that is artificial intelligence being used in the form of robotics and maybe giving an instruction to a robot to do a corrective action. So it's all interlinked, and that's how you create an efficiency into the system. Similarly, if you take another example, let's say transport. Now, when you talk about smart cars or connected cars or driverless cars, think of artificial intelligence and AI 5G coming together, because 5G will bring the latency, which is very important, because when you are driving a driverless car or a connected car, you know, a millisecond can miss the turn. A small millisecond can have an accident. However, when these come together, so the AI engine, which is sitting in the, wherever the intelligence is in the brain or the cloud or the servers where it is analyzing, and it analyzes the traffic around it. It sees that there is an accident which has happened. Avoid this route. It can also caution a driver and say, brake now, because if you've fallen asleep, because he can sense a car very close, even if there's fog. So you can't see the car, right, but the AI engine is telling you that brake now, and you can actually save lives. So I'm just giving you some very, very simple examples, but that's how AI and cloud coming together can really change the game and will change the game in the future.
Wow. So just as we come to a close of this session, it will be great to hear from you. What are some of the other use cases which I, as an end user, would be able to actually run on the 5G network, apart from the enterprise applications which you mentioned?
So, Gajendra, if I knew this answer, then I would be a billionaire. So everybody is looking for this killer application which will change the game in 5G, and I hope that we are able to find it soon. But the right answer to that is that there will never be a killer application. There are so many things that you can do 5G. All of them will be mature and to some extent be able to be monetizable in order to add value. However, if I look at let's say 5G, and I see all the applications that are possible, and I generally make a list of which are the low-hanging fruits, then which are the medium term, and which are the long term. Now, one of the easiest thing to do in 5G is fixed wireless access, and especially in a country like India, where rural broadband connectivity is so poor. We have only 20 million, even less than that, homes connected, and there is a need to connect more homes. But fiber penetration to the homes is a challenge. Fixed line getting to the home is a challenge. Can the 5G provide the home connectivity, and then there is a Wi-Fi network in a village or in a community where people can use that? So fixed wireless access, in my view, is one of the low-hanging fruits, which would be a game changer for rural connectivity. Then I would say The second application 5G will bring, initially 5G will bring huge bandwidth. It will bring big speeds and we'll be able to download and we'll be able to do a lot more. So in my view, I think cloud gaming is another very interesting but very monetizable use case. And why I say this is today, the Xbox, whether you have an Xbox or a Wii or one of these gaming tools, you first need a big equipment to run the gaming, and then you buy expensive games as much as 10, 15, 20, even $100, and then be able to do these gaming. Of course, online gaming has also become popular, but taking online gaming to the next level of adding virtual reality and doing a real-time online gaming between many users across the world with high definition gaming. So this is what I'm talking about, which 5G will possibly make happen. And if that happens, then you can imagine it's a billions and billions of dollars of industry of gaming, which can very easily migrate. So the same game that you are selling today at $20, you could market it at 20 cents, and the number of users that will opt for it. And this is big. The third thing I see is Industry 4.0, which is another big use case of 5G. And why I say this is much easier to do is because the industries across the world, including in India, have the plant and machinery, have the technology, which is upgradable to, so machines, and I'll give you an example of our own Chennai factory in India, where we said, why don't we make a showcase, and we converted that factory into Industry 4.0. And what we did was there was wire WAN LAN cable running across the factory connecting various parts of the machine. We took that all out, and every machine is now connected on a 4G SIM. You don't even have 5G.
Wow.
So we have made it into a 4G Industry 4.0 factory. But with what I'm trying to say is that the industries and the machines and the plants is something which is already modernized, very easily upgradable, and there is a want in them to create efficiency by Industry 4.0, which 5G or even 4G plus kind of technologies can bring. And the investment is also they are willing to do. So that's the beauty. They are willing to invest. Otherwise, you have to struggle for a business case and a use case and all those things, but they are willing to invest. So anyway, so that is number 3. And then comes the other use cases that we talk about, which is, let's say, stadium connection, or using virtual reality of watching a match which is running somewhere remotely,
right?
VR as an application. Then you come into things which are more difficult to do because you require a much the way you need to execute it is like smart agriculture, for instance, medical applications, for instance, etc., etc. So this is the way I would say the journey will flow. Amazing. And like we said in the beginning, slicing will be very important. So as and when slicing becomes popular, we will go up the value chain in terms of adding more and more applications which will be relevant for that.
Right. What an exciting future. I think that really brings us right to the end of this session. And I think we could really have an endless discussion on the number of use cases. Maybe we'll have a separate panel on that. Thanks, Amit, for your time, and thanks, General Kochhar, for your insightful views on the regulatory aspects.
Thank you, Gajendra. Thank you.